Hi everyone, this is Dr. Nak, and we are going to go over our practice exam number 2. Okay, so let's just get started right away. Now, number 1, solve the equation over the complex number system. Simplify your answer all the way. Okay, so for this particular problem, I would like to use the quadratic formula. So let me just write that out. So x equals negative b plus or minus the square root of b squared minus 4ac, whole thing dividing by 2a. All right, now in this case, our a is 5, b is 6, and then c is 2. Okay, so then what do we get? We got x equals negative b, so in this case, we get negative 6 plus or minus the square root of b squared. So 6 squared minus 4 times a times c, whole thing dividing by 2 times a. All right, now let's keep simplifying. So this is going to equal to negative 6 plus or minus the square root of negative 4, whole thing over 10. Now, square root of negative 4 is going to be square root of negative 1 times the square root of 4. Now remember, square root of negative 1 is I. So here what we're going to get is negative 6 plus or minus 2i, whole thing over 10. Okay, now let's keep simplifying. So this is going to be what? Negative 6 over 10 plus or minus 2 over 10i. So we could reduce that to negative 3 over 5 plus or minus 1/5 I. Okay, I think that's good enough. So let's put that in the solution set. Therefore, solution set is negative 3 over 5 plus or minus 1/5 I. And I'm going to box that for the answer. All right, so now let's get down to number 2. Use the following graph to answer the questions. All right, so let's go with A. Determine the minimum degree of the polynomial. Okay, so let me just try to count the number of turning points, because the minimum degree of the polynomial is the number of turning points plus 1. So let me just write this down. So this is what? Decreasing to increasing. So here is your turning point number 1. Increasing to decreasing, turning point number 2, turning point number 3. All right, now this one's little confusing, but this one is going to be another turning point right here. All right, and then there's another one starting from this way. So we have 1, 2, 3, 4, 5. We have 5 turning points. So let me just write it, 5 turning points. That means that the degree of the polynomial is going to be 1 more than the number of the turning points. So I'm going to say the minimum is 6 degree. All right, now next one. Approximate each real zero and state if its multiplicity is even or odd. Okay, so let's first determine all the zeros. I see a 0 here. I believe this is what? X equals negative 3, the way it's written. Now, another 0 will be right here. So this will be what? X equals to negative 1. And another 0 will be right here, which is what? Oh, it's 4. Okay, so let me just write that out. So zeros are x equals to negative 3, x equals to negative 1, and then x equals to 4. Those are all the zeros. Now let's figure it out. Either the multiplicity is going to be even or odd. So if I look around x equals to negative 3, notice that the graph touches the x-axis that are negative 3 and it bounces back. That means that, look at it, around negative 3, you got a parabola going on. So that means what? The degree of the parabola should be 2. So I'm going to say that at x equals negative 3, the multiplicity is probably going to be even. Actually, it will be even, and probably it's going to be maybe 2. Okay, now let's go with x equals to negative 1. Now notice that around x equals to negative 1, the graph is just crossing it directly through. Now if you look at it closely, that almost looks like a straight line going through. So the degree of that is going to be 1. And I believe that in your textbook it says single 0. So I'm just going to write it as multiplicity equals to 1. Okay, now let's go with the next one, x equals to 4. Now at x equals to 4, it's gonna be what? Let me see, let me just write it. I know already, you can probably see it in the blue already, but do you notice that this behavior like that? Oh, sorry, I didn't mean to cross that x-axis there. Anyways, this behavior right here is nothing but, what is that? The third degree polynomial. All right, so in this case, your degree is gonna be odd, which is, and the degree is probably gonna be 3. All right, so at x equals to 4, multiplicity is going to be odd, and most likely it's going to be a cubic polynomial, so it's gonna be 3. All right, so let's try to put all this information together to write the formula for the polynomial function of least degree. All right, so first let me just write it out like this. So our f of x is going to be some number a, which we'll figure it out in a minute, and then x plus 3, x plus 1, I'm just jotting down all the factors, and then x minus 4. So notice that if I said x plus 3 equals to 0, then x is going to be negative 3, which matches up with our answer. Similarly, for x plus 1, setting x plus 1 equals to 0, then your 0 is going to be what? Negative 1. X minus 4 equaling to 0, then your 0 will be 4. All right, so now let me just jot down the multiplicity. So around x equals negative 3, multiplicity is even. So let me just put 2. And x equaling to negative 1, multiplicity is 1. So I'm just going to put a little 1 there. Now, around x equals to 4, multiplicity is most likely going to be 3. All right, so it looks like that's going to be the big format of our function. Now let's find that a. So the next step is find a. Now, in order to do that, I know that this graph is a little bit drawn off to scale. What you need to do is determine at x equals to 0, so x equals to 0, what is the corresponding y value? So I'm just going to approximate because I know that this does not go through exactly this point right here, but this point is approximately what? Negative 600. Sorry for the ridiculously big number there. But anyway, so let me write that out. So when x equals to 0, it looks like y is approximately equaling to negative 600. All right, so now if I put that into an equation, that means what? F evaluated at 0 is going to be approximately negative 600. All right, so keep that in mind. And you know what? Let's compute f of 0 and then set that equal to negative 600 to solve for a. So ready? So we're going to be looking at the function over here. Now f of 0 is going to be a times 0 plus 3 squared. So that's going to be 3 squared. And then 0 plus 1 to the first. So that's 1 to the first. And 0 minus 4 to the third. So which will be negative 4 to the third. But look, that's all going to be approximately equaling to negative 600. All right, so let's just multiply all these guys together. So you can use your little scientific calculator if you like, but you should get over here, you should get negative 576 times the a is approximately equaling to negative 600. So that implies that our a is almost approximately equaling to what, 600, negative 600 over negative 576. So that should give us a positive answer, 576. Now if you reduce that, I believe that we should get 25 over 24. So that's gonna be the value of your a. All right, so finally our answer, so therefore I'm just gonna write the answer over here. Our f of x, it's gonna almost look like 25 over 24, and then x plus 3 squared, x plus 1, and then x minus 4 to the third. So that's gonna be our answer right here. Okay. Okay, number 3. A quadratic function is given by f of x equals 3x squared minus 5x minus 1. Now, part A, write the quadratic function in standard form. So first, you need to memorize what the standard form is going to look like. So the standard form is going to look like f of x equals a x minus h squared plus k. Now, if you have this equation, then your vertex is going to be h comma k. That's a k, sorry. Whoops. Okay, so keep that in mind. All right, so in order to make the general form into a standard form, we're gonna have to complete the square. I'm so sorry. All right, so let me just write it out. F of x equals 3x squared minus 5x minus 1. Now, in order to complete the square, leading coefficient has to be 1. So in that case, we're gonna have to factor the 3 out. So here let's rewrite the whole f of x by factoring out the 3. So here you're gonna have 3x squared minus 5 over 3x, and then what? And then minus 1/3. Okay, now what we're gonna do now is we're gonna complete the square in here, what's in the bracket. All right, so there are a few ways that you can do, but I usually go like this. So step number 1, sorry, let me just erase that. First, divide the middle number by 2. Dividing this guy by 2, what do we get? We're gonna have negative 5 over 6. Keep that in mind. All right, so let's rewrite. So this is 3, and then x squared minus 5 over 3x. Now, if I divide this 5 over 3 by 2, then you're gonna have negative 5 over 6. So what's gonna go into the next one's gonna be plus 5 over 6 squared. So basically, you're gonna have to go over here and add negative 5 over 6 squared. Okay, so that's gonna be what? A 25 over 36. Okay, and then you still got that minus 1/3. But the thing is, you added 25 over 36 into that expression. So that means you better be fair and subtract 25 over 36 as well. All right, now this can be written as 3 times x minus 5 over 6 squared. So that's gonna be the perfect square. These 3 terms gonna make that into a perfect square. And then you still have negative 1/3 minus 25 over 36. All right, so if you compute that, you should get, here you should get minus 37 over 36. So therefore, it looks like our f of x is going to look like 3 times x minus 5 over 6 squared minus, now I'm going to distribute the 3 to each term. So I'm going to go like this, 3 times this, and then 3 times that. So you can cancel the denominator, 3 by the, 3 into 36. And here what we're going to get is what, 37 over 12. All right, so that it looks like our f of x is going to look like, so let me just write it. F of x is 3, x minus 5 over 6 squared minus 37 over 12. So let me just box that for the answer. All right, so now let's go with part B. Find the vertex and classify it as a minimum or a maximum. Okay, so again, please look at the formula for the vertex. Vertex is denoted by h comma k. So in this case, our vertex, h comma k. So our h is what? 5 over 6. And then our k is negative 37 over 12. So that's going to be our vertex. Now, classify it as a minimum or maximum. Okay, so notice that our f of x, the leading coefficient is positive 3. So that means the parabola better be opening upward. So that means what? The vertex has to be at its minimum. Okay, so I'm going to say it's gonna assume a minimum value. Okay, so I'm just gonna write down the answer. So the vertex is 5 over 6, comma, negative 37 over 12. And maximum or minimum, I'm too lazy to rewrite minimum, so I'm just gonna circle it. Okay, so I'll just box this whole thing. There you go. All right, now, next one. Write the equation for the axis of symmetry. Now, axis of symmetry is jot down the jot down the vertex, and it's gonna go directly through at that vertex. Now, notice that at this vertex, it's always gonna be what? X equaling to the x value of your vertex. So here, all you have to do is equation of the vertical lines expressed by x equals something. So now x equals, what's the x coordinate of the vertex? 5 over 6. That's a 5, by the way, sorry. It looks so ugly. So here you're going to have x equals 5 over 6, and that's going to be the equation of the axis of symmetry. Oh my gosh. Sorry. Okay, so for part D, it continues. This is the whole entire thing is number 3. Find the x-intercepts and the y-intercept. Write them as points, meaning ordered pairs. So let me just rewrite the function that we're dealing with. F of x was what? 3x squared minus 5x minus 1. All right, so let's first go with the x-intercept. How do you find the x-intercept is you better set y equals to 0 and you just solve for x. Okay, so y equals to f of x. So what we need to do is we're going to have to set 3x squared minus 5x minus 1 equals to 0. And your job is to solve for x. I don't think we can factor this, so I'm going to use the quadratic formula. So our x is going to be minus b, so it's going to be positive 5, plus or minus the square root of b squared minus 4 times a times the c, whole thing dividing by 2 times a. Okay, so then what we're going to get is what? So here it looks like we're going to get, this is going to equal to what? 5 plus or minus the square root of negative 5 squared is 25, and add 12, so 37. Whole thing over 6. All right, so the x-intercept is gonna, so it's gonna look ugly, but use your scientific calculator just to get an approximate value. So our x-intercept is going to be, first one is gonna be 5 plus the square root of 37 over 6. And y value is always going to be 0 at the x-intercept. And then next one is what? 5 minus square root of 37 over 6, comma 0. Now if you type this in the calculator, your approximate value here is going to get plus 1 is what? 1 plus 85, comma 0. And approximately this guy is going to be negative 0.18, comma 0. That's a comma. All right, so ugly, but we got this. All right, now let's go with the y-intercept. Okay, so the y-intercept, how do you find the y-intercept? You're gonna set x equals to 0 and solve for y. All right, now, so if I do that, that's same thing as computing f of 0. So this is going to be what? 3 times 0 squared minus 5 times 0 minus 1. So it looks like our y is going to be just negative 1. So as a point at y-intercept, your x value is always going to be 0 and your y is going to be negative 1. Okay, so now what we need to do is we're going to have to gather all the information to sketch this graph. So let's see if we can do this. All right, so let me just draw the x and y axis here. Oh my gosh, pretend that's straight. And what? This is gonna go, where is our vertex? Vertex is what? Let me just write it down before I forget. Let me just make myself a note. From the previous problem, our vertex was 5 over 6, and then negative 37 over 12. Now, that's another ugly number, so approximately this is what? 0.8, comma, negative, what, maybe 3.1? Okay, so I'm just going to have to plot that approximate value. Now, so it's going to, y's value is going to go to negative 3.1. So let me just draw the y-axis here. Okay, oh my gosh, pretend that's straight. So I'm gonna make my grid as 1, 2, negative 1, negative 2, negative 3, 1, 2, and a 3, negative 1, negative 2, and negative 3. All right, so let's first jot down the x-intercept. Now, first one is 1.85 comma 0. So I'm just gonna guess 1.85 will be like maybe right here. All right, so I'm just gonna jot this guy down as approximately 1.85 comma 0. And the second one is what? Negative 0.18. So negative 0.2 approximately. So maybe let's just make this dot. So this is my approximation for negative 0.18 comma 0. Okay, now the y-intercept is the nice one. It's 0 comma negative 1. So 0 comma negative 1 will be right here. So let me just jot down. So this is 0 comma negative 1. And the vertex. Now let's jot down the vertex. Vertex is going to be 0.8, so which would be like maybe right here, comma negative 3.1. So it's going to be just a little bit below that. So I'm just going to jot this down as our vertex, which is approximately 0.8, comma negative 3.1. So now the axis of symmetry is going to go through the vertex. So let me just try to write a straight line here. Oh my gosh, this is a lot harder than it looks when you try to write it on the tablet. All right, that looks pretty straight, doesn't it? All right, so that's our axis of symmetry. So x is up. So I put x is approximately equaling to 0.8, but the exact value there is going to be x equals 5 over 6. Okay, now let's connect all the dots to graph this guy out. So it's probably going to look like, so excuse my graph, but everything has to go through this point. Oh my goodness. And then what? You're going to have to draw something symmetric to that side. Pretend that's a parabola. All right. And here it is. Not too bad. It does kind of look like a parabola, doesn't it? All right, so let's move on. Number 4. Find the x-intercept algebraically of the polynomial functions. State all zeros and their multiplicity. All right, so given that f of x, let me try to factor it out. Now notice that the greatest common factor is x, so I'm going to get that out. So this is same thing as, oops, sorry, that turned into red there. So this is going to be what? So to find the x-intercept, you're going to have to set y equals to 0 and solve for x. So what you need to do is you're going to have to set y, which is f of x equals to 0, and then get that GCF, greatest common factor, out of there. So here you're going to have x squared and what? Plus 6x and then minus 7. All right, now let me just put the 0 on the other side on the next line. So here you're going to have x. I believe you can factor this. You're going to have x plus or minus. Now I believe this is going to be 7 and a 1. Setting that equal to 0. Okay, so now that means what then? So all the zeros, or the x-intercepts, are x equals to 0, x equals negative 7, x equals to 1. All right, now let's look at the multiplicity. All the multiplicity, look at the exponents on each of the parentheses. Above the parentheses, that's all ones. So here you're going to have multiplicity equaling to 1. Multiplicity is 1, and same thing for that. Because look, this, so x is same thing as x minus 0. Right? So if you really wanted to look at it, this is x minus 0 to the first, x plus 7 to the first, and then x minus 1 to the first. It's going to go to equal to 0. So all the multiplicities are 1. All right, so answers. X-intercepts, I'm going to write it as 0, negative 7, and a 1. And real zeros and multiplicity, I'm just going to write all multiplicity is 1. Okay, so let me just box that for the answer. All right, now let's go to part B. Okay, so we're still gonna have to find the x-intercept, and we need to determine at the multiplicity at each of the zeros. All right, so let me just go with what? So let y equals to 0, and then you need to solve for x. So we have 4 terms going on here for this function f of x. So maybe let's try factor by grouping. Group up this 2, group up that 2. All right, now from the first group, I believe that I can factor out the x squared. Then here you're going to have what? X plus 2. And minus, from the second, the last 2, I should say, I should be able to factor out the 9. And then what? X and then plus 2 should make sense, because if I distribute the negative 9, you're going to get negative 9x. And then here you're going to have minus 18, which matches up with the top equation. So let me just erase that. All right, so now what? Now notice that these 2 terms has x plus 2 in common. So factor out the x plus 2. And then here you're going to have x squared minus 9. And let me throw the 0 on this side. All right, now you cannot relax yet, because look, x squared minus 9 can be factored by applying the difference of 2 squares formula. So this is what? X plus 3. And then x minus 3. So this is all going to go to 0. All right, so it looks like zeros are going to be x equals to negative 2, x equals to negative 3, x equals to 3, and how boring, multiplicity of all of it is going to be 1 again. All right, so let me just write x-intercepts are negative 2, negative 3, and a 3. Same thing at the zeros. And real zeros and multiplicities, I'm just going to write it as all multiplicity is going to be 1. Sorry for the boring problem. And here it is. Okay, number 5. Use the remainder theorem to find the remainder. So of course you're gonna have to know what the remainder theorem is. Please memorize this. So the theorem says that if a polynomial function f of x is divided by x minus k, then the remainder is going to be the value f evaluated at k. Isn't that pretty cool theorem? But anyways, let's take a look. Now, we're dividing by x minus 4, and this is going to be your f of x, and this is going to be your x minus k. So with that said, our k in this case is going to be 4. All right, now if I apply this theorem, if a polynomial f of x divided by x minus 4, then the remainder is the value f of 4. That's how you're going to have to translate it. So here what you need to do is compute f evaluated at k, which is 4. Okay, so our f of x is x to the 4th minus 1. So here what we're going to get is 4 to the 4th minus 1, which is what? 256 minus 1, which is 255. Now, that should be the answer. You can also check, by the way, so let's just check for fun by using the synthetic division. So the synthetic division, let's see. You're going to have a 4 here, and then what? Coefficient on the x to the 4th is 1. Coefficient on x to the 3rd is 0. Coefficient on the x squared is 0. Coefficient on the x has to be 0, and the constant term is 1. All right? So first you drop down that 1, and then 1 times 4 is going to give us 4. You add now 0 plus 4 is 4. The next one, you go 4 times 4, which is 16. Now you add them vertically, so you're going to have 16. Next one, you go 16 times 4, that's what, 64? And add 0 plus 64, so you're going to have 64. And the last one is going to be 64 times 4. Oh, you know what? Hold on 1 second. Sorry, I made a mistake. This should be negative 1, right? Because constant term is minus 1. Sorry about that. So in this case here, 64 times 4 is what? 256. Subtract 255. Boom. This is going to be the remainder. So it checks. All right. So the answer, remainder is 255. All right. Number 6, use synthetic division and the factor theorem to determine whether x plus 2 is a factor of that function right there. Now, if it is, explain why. If it isn't, explain why not. All right, so let me just jot down what the factor theorem is. Okay, so please also memorize this. So the factor theorem says that, let me just write it down right here. K is a 0. That's, sorry. Of f of x, if and only if, the notation for if and only if is double arrow, x minus k is a factor of f of x. Okay, So let me just say, so what we want to do is determine whether x plus 2 is a factor of this function right here. Now, I also want you to use the synthetic division to determine, to make sure that the remainder is going to be 0. All right, so let me see. So if I translate this into the theorem, we're going to say that instead of saying k is the 0 of f of x, if and only if x minus k is a factor of f of x, so we're going to say, so in this case, our k is going to be, negative 2. So our k is going to be negative 2. So we're going to say negative 2 is a 0 of f of x if and only if x minus 2, which is x plus 2, is a factor of f of x. Okay, so now what we need to do is we need to bust out that synthetic division. We want to make sure that it's going to, the remainder is going to be 0. All right, so here you're going to have negative 2. And I'm going to jot down all the coefficients. So you're going to have 1, negative 2. Coefficient on the x squared is negative 7. And then 8 and 12. None of the terms are missing, so we're good to go. All right, now, I'm going to just drop down to 1. 1 times negative 2 is negative 2. Now add, you're going to get negative 4. Now you go negative 4 times the negative 2, what is that? That's 8. And add vertically, you're going to have 1. Now 1 times negative 2 is negative 2. Add vertically, you're going to get 6. 6 times negative 2 is negative 12. Yay! Our remainder is going to be 0. All right, so therefore, according to the theorem, x plus 2 is a factor of f of x. All right, so let me see. Answers, yes or no? Yes, it is a factor. Now, explain. Because if x plus 2 is a factor of f of x, then f evaluated at negative 2 must be 0, which is same thing as saying that negative 2 has to be the 0 of f of x. Okay, so I'm just going to write it down. So if x plus 2 is a factor of f of x, then f evaluated at negative 2 must be 0. In which case, it is. Or you can say that, if x plus 2 is a factor of f of x, then dividing f of x by x plus 2, the remainder should be 0. You can also say that. All right, so either way is okay. However you want to explain it is okay, as long as it's legit. All right, so let me just box that for the answer. Here you go. Just in case, let me just write down what the heck I just said for the other answer. You could also say because if x plus 2 is a factor of f of x, then when you divide f of x by x plus 2, the remainder should equal to 0. In which case, it is. We just showed that work above. All right, so either way you want to answer is okay. Here we go. All right, number 7. Sketch the graph of the polynomial function by hand. Label the x and y intercept and state the zeros under multiplicity and the end behavior of the function. Okay, so I just give you this crazy looking polynomial, but let's first try to find the x-intercept and a y-intercept. Okay, so the x-intercept, you know what, I'm kind of running out of room here, but so x-intercept, you set y equals to 0 and then you solve for x. But before I do that, let me factor this out. So this is what, f of x is going to be x squared 2x plus 3 to the 5th. Now this is what, x minus 4 and then another x minus 4. Okay, so this is same thing as x squared 2x plus 3 to the 5th and then x minus 4 squared. Okay, so let's go back to the x-intercept. To find the x-intercept, you set that whole entire function equals to 0 and solve for x, which is also the 0 of the polynomial. So I'm going to write it as set y equals to 0 and solve for x. So we have what? X squared 2x plus 3 to the 5th, x minus 4 squared equals to 0, so that means what? X is 0 and x is negative 3 over 2 and then x is 4. So it looks like our x-intercept is going to be when x is 0, y is 0. When x is negative 3 over 2 or 1.5, negative 1.5, y is 0 and 4 comma 0. Okay, that looks like our x-intercepts. And let's go with the y-intercept. Oops. Sorry. Okay, so the y-intercept. So you're going to have to set x equals to 0 and solve for y. Alright, so if I do that, then here you're going to get y equals 0 squared 2 times 0 plus 3 to the 5th, and then 0 minus 4 squared. Alright, so, oh, look, this is just going to be 0. Do you see why? Because you're multiplying 0 times, what do we get? 3 to the 5th, and then negative 4 squared, so this is going to be 0. Alright, so the y-intercept is going to be when x is 0, y is 0. So let me just box all that important information in red. Y-intercept, and then here's our x-intercept. Okay, so now let's go with the zeros and multiplicities. Okay, so the zeros are x equals to 0, x equals to negative 3 over 2, and x equals to 4. Alright, now let's go back. Now x equals to 0, so we're looking at the function x squared. So in this case, we're going to have the multiplicity is going to be even. In fact, it's going to be 2. Multiplicity is 2. So that means what? Your graph's going to behave like a parabola. So keep that in mind. So your graph is going to bounce back like this at x equals to 0. All right, now let's go with x equals negative 3 over 2. So now we're looking at the factor 2x plus 3 to the 5th. So in this case, we got the multiplicity to be 5. Now, so that means our function is going to behave like the 5th degree function. So it's going to look something like this. All right. Now, let's go with when x equals to 4. So you're looking at the factor of x minus 4. Exponent, that is 2. So we got multiplicity equaling to 2. So in this case, it's going to behave like a parabola again. So this shape needs to happen around that point. Okay. Now let's go with the end behavior. Now notice that if you multiply everything out in f of x, do you see that you're gonna be, the first leading coefficient is gonna be what? X squared times 2x to the fifth times x squared, which is still gonna be positive x to the 9. Okay, so in this case, leading coefficient is gonna be positive no matter what. So that's gonna behave, the graph will behave just like this. If it's negative, it's gonna go the other way around. All right, but any case, let's take a look at this. Now, you can conclude the end behavior when you're done graphing it out. So I'll just wait till we graph this out, we sketch this out a little bit. Okay, so let me just try to graph this. Okay, so let me just go with 1, -1, -2, -3, 1, 2, 3, 4. Y-axis is going to be drawn off the scale, so we'll deal with that in a minute. But anyway, so let me just jot down -1, -2, -3, 1, 2, 3, and a 4. Okay. So now let me just jot down all the x-intercepts. So that all the x-intercepts are 0, 0, which is also the y-intercept. And then negative 3 over 2, so that's negative 1.5. So this part is going to be negative 3 over 2 comma 0. Now 4 comma 0 is right here. So that's our 4 comma 0. Okay, so that's where the graph's going to change its behavior. All right, so now notice that your graph is going to be going down this way and then up this way no matter what. So keep that in mind. Okay, so it looks like, let me see, let's go in order. X equals to negative 3 over 2, multiplicity is 5. So your graph is going to behave something like this at that point. Let me just draw this. Kind of like that. Okay, that mimics the the 5th degree polynomial. All right, and then what? The tail end is going to go towards this way. All right, now let's go with the x equals to 0. We have a multiplicity to be 2. And that's also the x-intercept and a y-intercept. So your assumption is what? The graph's going to look something like, it's going to do something like that over here. All right, so my guess is this is going to connect like this somehow. All right, and then now let's go with when 0 is 4 and multiplicity is again 2. So at x equals to 4, this behavior must happen. Now, since the tail end is going to go upward, I'm just going to go like that. Okay, now I'm not quite sure what's going to happen between x equals to 0 to 4, but I'm going to assume that it's going to do something like this. All right, now in fact, at x equals to 3, if you plug the x equals to 3 into the function, your y value is going to be something ridiculously big. So it's going to be 53,144, I believe. All right, so that's why I told you that I'm going to draw this completely off the scale. The y-axis is going to be completely off the scale. But anyways, this will be the sketch of the graph. All right, now let's go with the end behavior. Okay, so let's look at the tail end of the graph. So as x goes to negative infinity, so that means x is going to negative infinity. Look at the tail end of the graph. Where is it going? As x increases, the tail end of the graph is going to negative infinity. So in this case, we write f of x is going to go to negative infinity. Those of you who's going to be taking calculus, we write this as the limit. As x goes to negative infinity of f of x, this is going to go to negative infinity. But you don't have to write that. But if you want to impress me, go right ahead. All right, now let's take a look at the end behavior on the right. Okay, now as x goes to positive infinity, so now we're looking at this direction now. Where does the tail end of the graph go? Well, as x increases, the tail end is going to what? Shoot up to positive infinity. So as x goes to positive infinity, in this case, our f of x will also go to positive infinity. Now, those of you, again, who's interested in taking calculus, will write this expression as limit. As x goes to positive infinity of f of x, this is going to go to positive infinity. But again, you don't have to write that. Just give me this and I will be super happy. Okay. Okay, number 8. For the following rational function, find the domain in interval notation, intercepts, equations of the asymptotes, express your intercept as points, and if you have any asymptotes, denote whether it's vertical, horizontal, or slant, and sketch. All right, so let's get started on this one. All right, so first thing first, make sure to factor out the rational functions as much as you can. So in this case, let me see. Okay, so the top should factor out to be what? X, and then maybe plus 3 minus 1. And then the bottom is going to be x plus 1, and then x minus 1. Okay, I think this is as much as we can factor. Now, yes, notice that you can cancel out the x minus 1, but don't do that yet because we still need to get the domain of the function. To find the domain of the function, you want to keep the denominator as is. Do not cancel out anything. So the domain portion is going to be what? X cannot equal to negative 1, and then also x cannot equal to 1. So to get that in the interval notation, let me see. Here's negative infinity, positive infinity. X cannot be negative 1. X cannot equal to 1. So everywhere else, our rational function is defined. So just translate this into an interval notation. So here what we're going to get is negative infinity to negative 1, open, union, open, negative 1 to 1, open, union, and open 1 to positive infinity. All right, now that's the domain. Now, notice that we can cancel out the x minus 1s. That means that we're going to have the removable discontinuity at x equals to 1. Meaning, along the graph, at x equals to 1, you're going to have a little hole on there. Okay, so now let's go with the x-intercept. Now, to find the x-intercept, you're going to set y equals to 0, and you're going to solve for x. Now, if y equals to 0, only the numerator has to go to 0. Now, to find the x and y-intercept, look at the reduced rational function. In this case, it's going to be x plus 3 over x plus 1. So, to find the x-intercept, just set the numerator equals to 0 and solve for x. So that implies that x is negative 3. So as point, in order to pair, you're going to have negative 3, comma 0. Oh, let me just box the domain. And here is the x-intercept. Now, the y-intercept is you set, x equals to 0, and then you're going to solve for y. So again, you're looking at the reduced rational function. So here you're going to have y equals 0 plus 3 over 0 plus 1. So this is going to be 3. So here our y-intercept is going to be 0, comma 3. Okay, now equation of asymptotes. So first thing, we are guaranteed that we're going to have a vertical asymptote at x equals to negative 1. because that's where the rational function will become undefined. Okay, and also notice that f of x, the leading coefficient on f of x is 1, and the bottom, the denominator's leading coefficient is also 1. So basically f of x behaves just like x squared over x squared, which is going to equal to 1. So we're going to have a horizontal asymptote at y equals to 1. Okay, so let me just box this. So that's the vertical, and this is going to be the horizontal. So let me just type vertical, horizontal. Vertical is x equals to -1. Horizontal, y equals to 1. And don't forget, removable discontinuity at x equals to 1. Okay, so let me just jot down what the graph's going to look like. Okay, so let's go 1, 2, maybe 3. -1, -2, -3, like this. All right, so I'm just going to label this as 1, 2, 3, 1, 2, 3, and a 4. And -1, -2, -3. All right, so let's just first jot down the asymptotes. So x equals -1 would be right over here. So this is our x equals -1. Now y equals to 1 will be the horizontal line. So this is y equals to 1. Okay, the asymptotes are done. Now let's jot down the intercept. And intercepts are -3, 0, so which will be right here. And also, that's it, right? Oh, yeah. And the y-intercept is 0, 3. Okay, and for sure we're gonna have a hole at 1. Now, to find out what the corresponding value when x equals to 1, although the function is not defined there, all you have to do is compute f of 1 to determine where the hole is going to be on the graph. Now, when you do this, make sure to plug it in the function where you crossed, after you crossed out the x minus 1s. So here, we're gonna have f of 1. This is going to be 1 plus 3 over 1 plus 1. So this is going to be 4 over 2. So it's going to be at 2. So when x equals to 1 and y equals to 2, there is going to be a hole there. So this is going to be the hole. All right. So 1, 2, that will be right here. So it looks like our graph is going to go something like this. You know what? I need to extend this vertical asymptote a little bit. And it has to go through the y-intercept. And then I'm going to go through the hole. And there's the horizontal asymptote. So here is the top piece of the graph. Now, to draw the graph in this region here, right, you know for sure that our graph has to pass through x equals to -3. So my guess will be our bottom graph is going to look something like this towards the vertical asymptote. Now, if you want to get the middle value, let's just say what I mean is that when x is -2, what is going to be my y value? That will give me more precise way to graph it. You don't have to do this step if you don't want to, but let me just do it for fun of it. Okay, so let me just, where in the heck can I write this? Okay, so you know what? Let me just write it here. So when x equals to -2, what I'm going to do is, what is the corresponding y value? So again, I'm going to compute f of -2. So that's going to be -2 plus 3 over -2 plus 1. So this looks like it's going to be 1 over -1. So it looks like -1. So for sure, you know that your graph is going to pass through -2, -1. So that is, let me just box this. So where in the heck is that? -2, -1. So your graph has to pass through here. All right, so then let me just try to draw the graph. Go through the x-intercept. Oh my gosh. Okay, here we go. Okay, you get the idea. Anyways, so here it is. Okay, for the next problem, solve the inequality, express your answer in interval notation. We have x minus 5 over x minus 3 is greater or equal to 0. Now, when you see a greater or equal to 0, it's the equivalent of saying find all the x values where x minus 5 over x minus 3 is going to be positive. So keep that in mind and let's do this. So the easiest way for me to do is draw a little number line. So let me just go like this. So pretend that this line is for x minus 5 and this line is designated for x minus 3, and the last one is going to be x minus 5 over x minus 3. Now in order to do this, find a 0 for x minus 5 and x minus 3 and pretend that those are the number lines. So when x minus 5 is 0, so the 0 of it is going to be x equals to 5. And then do the same thing for x minus 3. So the 0 of it is going to be x equals to 3. So first, let me jot that down. So now x equals to 5. So that's, pretend that's 5. X equals to 3. So that's smaller than 5. Okay. Next, since this is greater or equal to, you don't really have to worry about, too much. However, look at the denominator. Denominator is x minus 3. Now remember that we cannot have 0 on the bottom. So what's going to happen is that there is going to be a vertical asymptote at x equals to 3. So here, no matter what, 3 will not be included in the solution set. So I'm going to put an open circle around it just to so that I remember that, okay, x equals to 3 cannot be the solution. But anyway, so next step, all you have to do is this. Pick any number that's from -infinity to 5. So maybe, what's in here? 4, right? 4 is smaller than 5. So if I plugged it in 4 in place of x, 4 minus 5 is -1, which is basically we're going to have a negative value. So that tells us that on this portion here, where all these numbers on the left of 5 are going to be negative. Now, pick any number from 5 to infinity, so let's just pick 6, right? So if I plugged it in 6 in place of x, you're going to have +1. So that tells us that all the region here are going to be positive from 5 on. Okay, so now we're going to do the same thing for x minus 3. All right, so plug any number that is going to be less than 3. So let's pick 2. And then plug that 2 here, and just to determine the sign, is it going to be positive or negative? So if I plugged it in 2, 2 minus 3 is -1. So here we're going to have a negative. So all this region here, we're going to have a negative, and that means that all this region here are going to be positive. Okay, so next, jot down the 3 and a 5 again. So this is going to be 3 and a 5, and make sure to put a hole right there. Now this is what we need to do. So since this is x minus 5 over x minus 3, right? Remember, if I have a negative over a negative, it becomes a positive. If I have a negative over a positive or vice versa, it's going to be negative. And also, negative on the top over negative on the bottom should give us a positive. So keep that in mind. Okay, so now top, look at the top. Top is negative over bottom is negative. So here I have a negative over a negative from -infinity to 3. So in that region, we're going to have positive. That's going to be a positive value. And then if you want, you could put here -infinity and then infinity. To me, that's easier for me to draw the interval notation. Now let's go in between 3 and a 5. Okay, so focus on 3 and a 5. Now, for the 5, it's going to be negative, right? So we're going to have a negative over a positive in between 3 and a 5. So negative over positive is going to give us negative. Okay, now we're going to do the same thing for from 5 to infinity. So here we're going to have a positive over a positive. So here we're going to have a positive. Boom, almost there. Okay, so now let's go back to the question, right? So this is basically telling us that find where x minus 5 over x minus 3 is positive. All right, so which region is that? Well, to me, that will be this region from negative infinity to 3. Do not include a 3. That's the reason why I have an open circle around the 3. And then the middle part, in between 3 and a 5, our function assumes the negative value, so we don't care about that because we want to find where it's positive. So here we're going to have, over here, oh, sorry, this should be a closed bracket because function is defined at 5. So you're going to have a 5 to infinity and then put a union in between, then boom, we're done. So here is our final answer. And we're done with the first part of the exam. Now, your actual exam is going to look just like this. So make sure that you practice enough and then also go over some of the similar problems from your textbook. You got this.